Here we're asked to solve an equation for the letter y. It says y subtract the negative number negative 1/12. Well, subtracting a negative is effectively adding the opposite, which is a positive, and that's still equal to negative 1/12. To solve the equation, we need to remove the 1/12 from the left. We can do that by subtracting 1/12 on the left, and we subtract 1/12 on the right. Notice when we subtract the 1/12 on the left, the 1/12s are gone. So that's like just picking it up, it's gone, and dropping it on the other side. And when you drop it on the other side, it's the opposite of what we started with. So we have y equals a negative 1/12 and a negative 1/12. Adding like signs, we're going to get negative 2/12. That, of course, reduces by 2, so it's negative 1/6. And that is a simplified fractional answer. Well, the next problem we have to solve, next equation we're solving is written down. We need to distribute the 4 across the parentheses, so that's going to be 8 minus 4t minus, think of it as minus 1. Distribute the minus 1 across the parentheses, that's going to be minus 3. And a minus times a minus would be plus 2t is all equal to 2. Combine like terms, and I like to underline things that are alike. So 8 and a minus 3 are like quantities. That's a 5. Another pair of like quantities is the t terms. And negative 4t plus 2t is negative 2t. And that's all equal to 2. Now we want to isolate the unknown t. I'm going to move the 5 to the right. So I'll leave negative 2t there. When I move the 5 to the right, it's gone from the left. And when it shows up on the right-hand side, it's always the opposite, which gives me a negative 3. And to solve for t, divide both sides by the coefficient of t, which is negative 2. That gives me t. 2 negatives are a positive, gives me positive 3/2. Word problems bother many of us, including myself. Let's read the problem slowly and carefully. 20 minutes after a father left for work on the bus, he noticed that he had left his briefcase at home. His son left home driving at 39 miles per hour to catch the bus that was traveling at 27 miles per hour. How long did it take the son to catch the bus? Well, I realize this is a motion problem, so I'm going to put the formula d equals rate times time down. And I'm going to make a little chart. And I'm going to put on the left side father, and then son. Notice that the father left right away, the son left later and caught up to the father, so they travel the same distance. The son left home driving at 39 miles per hour. That's the speed of the son. To catch the bus that was traveling, the father was traveling at 27 miles per hour. And the son caught up to the father, but 20 minutes, he left home 20 minutes later. Well, we need to convert 20 minutes into parts of an hour. 20 minutes, I believe, is 1/3 of an hour. Okay. So, how much time did the father take to travel? He took t time. The son didn't leave at the same time, he left later. So we need to subtract 1/3 of an hour from the time that the father took. That's t minus 1/3. And I'm going to put a parenthesis around it. And these are equations, 2 separate equations where the d is the same. So I'm going to set the top equation 27t equal to the bottom equation 39 times t minus 1/3. Now to solve, I'm going to distribute 39 times t. 39 times a third, I'm going to reduce 39 by 3, or divide it up by 3, so I'm going to come up with negative 13. I now want to isolate terms. I'm going to move negative 13 to my left and 27t to my right. Do the arithmetic. That's going to be equal to 12t. Solving for t, t is equal to 13/12. That's the time for the father. The question says how long did it take the son? The son took less time. So the son's time is t minus a third. So that's 13/12 minus a third. Getting like denominators, a third is equal to 4/12. So 4/12 and 13/12 is 9/12. And 9/12 reduces to 3/4. So it took 3/4 of an hour for the son to catch up to the father. Let's read this problem. The office manager of an election campaign office needs to print 6,000 postcards. It costs 2 cents to print a large postcard and 1 cent to print a small postcard. If $96 is allocated for printing postcards, how many of each type of postcard can be printed? Well, this is a monetary or cost problem. So the cost of of printing the small cards plus the cost of printing the large cards must equal the total cost allocated for printing. There are 6,000 cards in all. Let's say X is the number of large cards. We don't want to use another letter for small cards, but because we know there are 6,000 cards, then there must be 6,000 minus X for the quantity or number of small cards. All right, what is the cost to print the small cards? It's 1 cent. It's 1 cent to print the small cards. So it's going to be 0.01 times 6,000 minus X. That's the cost per card times the number of cards. The cost to print the large cards is 2 cents, 0.02, times the number of large cards, which is X. And that gives me the total cost, or the total amount of money I can spend, $96. This happens to be in dollar format, but if I multiplied by 100, each term, this term, this term, and this term, I would have 1 times 6,000 minus X plus 2X equals 9600. So here the equation is in penny format, that's in dollar format. Getting rid of the parentheses, I have 6,000 minus X plus 2X is equal to 9,600. And what we combine, we're going to have X plus 6,000 equals 9,600. Solve for X by moving 6,000 to the right. That gives me 3,600. That's the number of large cards. The number of small cards would be 6,000 minus X, or 6,000 minus 3,600. And that's 2,400. So 2,400 small cards. So when you're working with word problems, yes, they can be challenging. You have to understand them. You need to read the problem several times and break it down into small pieces. And when you do that, then it becomes easier and easier, especially with more and more practice. Let's read this problem. How many gallons of 60% antifreeze solution must be mixed with exactly 100 gallons that's only 30% concentration to get a mixture that is 50% antifreeze? Well, it's nice to draw a little picture. So I'm going to have a box here, and this box has 100 gallons, but it's only 30% antifreeze. So it's only a small part of it. 30% is antifreeze. And that's we're going to how many gallons of 60% antifreeze? So I've got another container, and I don't know the size of this container, but we're trying to find out how many gallons. So we're going to say it's X gallons. But this, how many gallons is 60%? So this has a stronger concentration. 60% is antifreeze. And we want to mix these two. So we're going to dump the 100 gallons as well as an unknown amount, X gallons, down into another container. But that container is going to have 50% antifreeze. But how many gallons does it have? Well, it has the 100 gallons, and it has the X gallons of solution of the mixture. So this is a mixture down here made up of these two solutions. Well, let's write an equation that makes sense. Let's write an antifreeze equation. Well, how much antifreeze is in this 100 gallons? It is 30% of the 100 gallons. 100 gallons is the solution, 30% of it is the antifreeze. I want to add that to the amount of antifreeze from the unknown gallonage. So that's going to be 60% of X. When we dump these two quantities down into the mixture, we have a 50% antifreeze, but how much mixture do we have? We said a moment ago we have 100 plus X. So there's your antifreeze equation. Let's get rid of the percents. So that's 0.3 times 100. This is 0.6 times X. This is 0.5 times 100 plus X. Multiplying out, we're going to have 30 plus 0.6x. 0.5 of 100 is going to be 50 plus 0.5x. Moving 0.5x to the left and subtracting, we have 0.1x. Moving 30 to the right and subtracting, we have 20. Dividing both sides by 0.1, whereas we have X as 200 gallons. So we must be using 200 gallons at 60% combined with 100 gallons at 30% to get a 50% solution. This is as I said, a mixture problem, and you just have to still deal with the same units: antifreeze with antifreeze, water with water.